This video is our beginning journey to what is doing something called finding trig ratios. Okay, so we're going to start off with things that we know. For example, we know that in any given right triangle, we have this thing that allows us to decide on the first three trigonometric ratios, the one for sine, cosine, and tangent. And we said that the sine of an angle would be opposite over hypotenuse. The cosine of an angle would be adjacent over hypotenuse, and the tangent of an angle would be opposite over adjacent. And these are our three main trigonometric ratios that kind of guide us moving forward. Now, what we're going to introduce right now is what is called the reciprocal trigonometric functions. And the reciprocal trigonometric functions do match up with these three originals, but they're kind of a variation or built off of them, or they're reciprocals. So, involving the sine, if I look at its reciprocal, I have a function that is known as cosecant. Cosecant. And the cosecant function is abbreviated CSC. Now the cosecant function I know is the reciprocal of the sine function. So 1 over sine. And if I look at it as a ratio and matching it up to the SOHCAHTOA idea, this would give me the ratio of hypotenuse over opposite. Okay? Our second function is the cosine function. Its reciprocal function is known as the secant function. It's abbreviated SEC. And I know that the secant is the reciprocal of the cosine function. Now, if I take the reciprocal of the cosine, that would give me hypotenuse over adjacent as its ratio. The reciprocal of the tangent function is known as the cotangent. It is abbreviated COT. So that would be 1 over the tangent of theta, or adjacent over opposite. So again, sine, cosine, and tangent are our three trigonometric functions. The reciprocal of sine is cosecant, the reciprocal of cosine is secant, and the reciprocal of tangent is cotangent. Now, how I keep these straight in my head, sorry, I needed a drink there. How I keep these straight in my head for which ones match up with which, tangent and cotangent are kind of simple to match them up. You know the cotangent is the reciprocal of the tangent. That makes sense. But if you notice sine and cosecant, cosine and secant, those don't kind of match up as nicely. So what I remember in my head is when you look at the trig ratio and its reciprocal, S and C always go together. When I say S and C, I'm referring specifically to their first letters. S and C always go together. Okay? So what we're going to be focusing on today, it's a pretty simple exercise, is getting used to all 6 of these trigonometric ratios. All right? So they want us to find the value of each trig function indicated. In this first one, they want us to find the sine of theta. Now I know that the sine of theta is opposite over hypotenuse. The problem is I don't know the hypotenuse. But since it's a right triangle, I know that the Pythagorean Theorem will find for me the hypotenuse. All right? I know that the hypotenuse squared is equal to each of the legs squared and added together. So the hypotenuse squared, let's see, that would be 12 squared plus 16 squared equals 400. Or h, by taking the square root, would be 20. To find the sine of theta, I'm going to take opposite, which would be 12, over hypotenuse, which would be 20. And I always need to simplify these fractions. So this one, both of these are divisible by 4. So that would leave me with 3 over 5. The sine of theta is 3/5. All right, how about the cosine of theta? Well, in order to do the cosine, I need to know adjacent, I've got it, and hypotenuse, I've got it. I don't need to do anything else other than write the ratio. So the cosine of theta would be adjacent, 15 over hypotenuse, 25. Simplify those fractions. Both are divisible by 5. I have to simplify it and leave it as a ratio, as a fraction. Sorry, my throat's getting a little dry today from all these videos. Okay, the next problem, find the tangent of theta. So the tangent of theta, I know, is opposite over adjacent. I don't know the adjacent side. But I can use the Pythagorean Theorem, which says 3 radical 5 squared has to equal 3 squared plus a squared. So 3 radical 5 squared would be 45. All right. How I know that very quickly is I take that 3 and I want to put that 3 in the radical. So if I took the square root to get it out of the radical, I would square it to get it in the radical. That's how I get square root of 45 squared is 45. Is equal to 9 plus a squared. If I subtract 9, I get 36 is equal to a squared, or a is equal to 6. So now I know a. I know that the tangent function would be opposite 3 over adjacent 6, or the tangent of theta is 1/2. All right. Now I got the cosecant. All right. I know that the cosecant is the reciprocal of sine. I know that sine, I needed opposite and hypotenuse. I don't know the hypotenuse. So I'm going to find the hypotenuse first by the Pythagorean Theorem. 12 squared plus 16 squared, or h squared is equal to, let me use a calculator, 12 squared plus 16 squared. Oh, I did that before, didn't I? So therefore I know that h would be 20. All right. If the sine is opposite over hypotenuse, then the cosecant is hypotenuse over opposite. And then if I simplify this fraction, it simplifies, let's see, both are divisible by 4. Yeah, so that gives me 5 over 4. The cosecant is 5/4. How about the next one, the secant? I know that the secant is 1 over the cosine, or the reciprocal of the cosine. I know that the cosine is adjacent over hypotenuse. I don't know the hypotenuse. I'm going to use Pythagorean Theorem to find it. H squared is equal to 7 squared plus 24 squared, or h squared is equal to 7 squared plus 24 squared equals 625. And the square root of 625 would be 25. Okay? So 1 over the cosine is adjacent over hypotenuse. To find the secant of theta, I'm going to do hypotenuse over adjacent. I can't simplify it. I'm done. Okay? And the last one here, let's do the cotangent. Now the cotangent says it's the reciprocal of the tangent. And the tangent, by definition, is opposite over adjacent. Okay, I don't know the opposite, so I'm going to have to find it. And I've got O squared. That's not 0, that's O squared for opposite. Is equal to, whoa, what am I doing there? Sorry, little brain cramp. Let me fix this up. I have to start with the hypotenuse. So 6 squared is equal to, I'm going to abbreviate it, OPP squared. Whoop. OPP squared plus 5 squared. All right, so 36 is equal to OPP squared plus 25. Subtract 25, that gives me 11 is the opposite squared. So then the opposite would be the square root of 11. Okay. So I know that the tangent is opposite over adjacent. Therefore, the cotangent of theta would be adjacent over opposite. But remember, you cannot have a radical denominator. So I need to rationalize this. And if I rationalize it, remember you're going to multiply top and bottom by the square root of 11. I would get 5 radical 11 over 11. This is the simplest form of the cotangent. Sorry, I abbreviated cosine there. Cotangent of theta would be adjacent over opposite, and then I simplify it. Let me know if you guys have any questions. Good luck.